So today we are going to learn one of the most important topics, that is introduction of trigonometry. So the word trigonometry is derived from the Greek word which means tri, that is three, gon stands for sides, and metron stands for measure. So trigonometry as a whole is a study of relationship between the sides and angles of a triangle. So the application of trigonometry is a lot. Like it's used to solve for heights and distances. Like if you want to find the height of your house, or if you want to find the height of a tree, you can find using trigonometry without measuring it. Or if you want to find the distance between you and your friend's house or your home to the school, you can find the distance without measuring it. Lots of big application, that is the distance of the star to the earth or the distance from the moon to the earth is can be also found using trigonometry. So basically the application is that it is used to solve for any heights and distances, and you can find without measuring it. Let's go through the important concept of trigonometry. So if you consider a right triangle ABC, right angled at B. Now the basic understanding you need to have is to find three sides: opposite, hypotenuse, and the adjacent side. So in this triangle, if you consider the acute angle C, so the side opposite to the acute angle is going to be AB. So that is the opposite side, which is a side opposite to the acute angle you consider. Now, hypotenuse. Hypotenuse is a side opposite to the right angle, which is the longest side, and that's the hypotenuse. And the adjacent side is a side which is the arm of the angle, but the one apart from the hypotenuse. So BC. So adjacent is the side which is the arms of the acute angle you consider, but apart from the hypotenuse. So that's how you find opposite, hypotenuse, and adjacent. Now, if you take the same right triangle, ABC, right angled at B. This time, if you consider the acute angle A, so the opposite side is going to be BC, the hypotenuse is the one opposite to the right angle, so that's going to be AC, and adjacent is the arm of the angle, acute angle, apart from the hypotenuse, that's AB. So you could see that when you compare both the triangles, the hypotenuse stays fixed because it has nothing to do with the acute angle. It is always the one opposite to the right angle. But opposite and adjacent, they flip around as per the acute angle you consider. Now, with these three sides, that is opposite, let me take it as O, adjacent A, and hypotenuse. With these three sides, you can have different combinations of ratios. That is, you can have O by H, H by O, A by H by A, O by A, and A by O. And these 6 different ratios, you are giving mathematical names to it. That is sine theta. The theta is the angle you consider, the acute angle. Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. Cosec theta is hypotenuse over opposite. That's a short form for cosec. And sec theta is hypotenuse over adjacent. Cot theta is adjacent over opposite. So now to remember this, you could see that this is the most important among the ratios. So if you remember these 3, you can understand the other 3, because you could very well see that cosec is a reciprocal of sine. Sec is a reciprocal of cos, and cot is a reciprocal of tan. So the first 3 are important. Now to remember these 3, you can have a short form connected. That is so ka tova. There is a saying related to this, that is some old horses can always hear their owner's approach. You don't have to remember the saying, but the most important thing is that remember this. So ka tova. So this will help you to remember these 3 formulas. So ka tova. So ka tova stands for sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent, and the other 3 are the reciprocals. In triangle ABC, right angled at B, AB is given as 24 centimeter, BC is 7 centimeter. Determine sine A, cos A, and also sine C, cos C. So over here, we have to draw a right triangle, right angled at B. So right triangle, right angled at B. Now you can name A and C however you like. The only important point was that it is right angled at B. So that's already been taken care of. Now AB is given as 24 centimeter. BC is given as 7 centimeter. So before we start solving for this, we will have to find the missing side, that is AC. To find AC, we can use Pythagoras theorem. So angle B is given as 90 degree, that's given. So here I can use Pythagoras theorem, that is AC square is going to be AB square plus BC square. The Pythagoras theorem. So AC square we need to find, that is going to be 24 square plus 7 square, which is 24 square is 576 plus 49, that is 625. Now to solve for AC, that's going to be root of 625, and square root of 625 is going to be 25 centimeter. So we have solved for the unknown side, 25 centimeter. Now, answering to the first question, we need to solve for sine A. So the acute angle we have to consider is A, because it's mentioned over there, sine A. So with respect to A, the opposite side, because sine is opposite over hypotenuse, using the trick which I mentioned. So curve over. So sine is opposite over hypotenuse. Now opposite. So opposite of angle A, that's going to be 7 over hypotenuse is the one opposite to the 90 degree. So 7 over 25. Now solving for cos A. So cos is adjacent by hypotenuse. So adjacent over hypotenuse. So this time again we have to consider the angle A. So angle A, the adjacent side is 24. The one next to it, apart from the hypotenuse. That is adjacent side. Now the hypotenuse is the one opposite to 90 degree. That is 25. So that's the first part of the question. Now to solve for the second part, sine C. So this time the angle to be considered is angle C. So when I consider angle C, sine, we know the formula, opposite over hypotenuse. So opposite of C, angle C is going to be 24 over hypotenuse is the opposite to 90 degree, 25. And now cos C is adjacent over hypotenuse. So adjacent of C is going to be 7, adjacent to the side next to the angle, the arm of the angle, apart from the hypotenuse. And over the hypotenuse is 25. So 7 over 25. So that's how you solve this. If sine A is equal to 3 by 4, calculate cos A and tan A. So let's draw a triangle. A right triangle. You can name it any way you want because the sides or the names are not given. But make sure that sine A, since it's sine A is 3 by 4, make sure that the angle A is the acute angle. That's the only thing you have to note from the question. Now sine A is given as 3 by 4. So we know that sine is opposite over hypotenuse, that is 3 by 4 by using that formula. So curve over. So sine is opposite over hypotenuse. So from here I could say that when you consider the angle A, the side opposite to angle A, let's take it as 3 because opposite, let's consider it as 3, and hypotenuse, let's consider it as 4. So the one opposite to the 90 degree, that's the hypotenuse. Let's take that as 4. So now the unknown side is AB. So we have to figure out AB. So we can figure out AB by using the Pythagoras theorem. So we know that AB square plus BC square is equal to AC square by Pythagoras theorem. So AB we don't know. So AB square plus 3 square equal to 4 square. So AB square will be 4 square minus 3 square, that is 16 minus 9, that is 7. So AB will be square root of 7. So we have found AB, that's root of 7. Now we need to find cos A. So cos A, cos is, we know that it's adjacent by hypotenuse. So the formula is adjacent over hypotenuse. So we'll have to take the adjacent of angle A. So the adjacent of angle A would be root 7. That is, it's the arm of the angle apart from the hypotenuse. So that's root 7 over the hypotenuse is root 7 over 4. Now you have to find tan A. So tan A, the formula is TOA, that is opposite over adjacent, opposite over adjacent. So opposite of A is 3, and the adjacent, the one next to that, is the arm of the angle apart from the hypotenuse. So that's 3 over root 7. Given 15 cot A is equal to 8, find sine A and sec. So 15 cot A is equal to 8. So from here, I would get cot A is 8 over 15. The 15 taken to our side will be division. Now let's draw the figure. So draw the right triangle. Since cot A is given, so A is acute angle, so you can consider any one of the acute angle as A, and other vertices you can name however you want. So now cot A is 8 over 15. So cot A, we know that the formula is cot over, and cot is the reciprocal of tan. So tan is opposite over adjacent. So cot will be adjacent over opposite. So adjacent over opposite is 8 over 15. So from here, adjacent, we can take it as 8. So one adjacent to angle A, that's going to be 8. And opposite of angle A will be 15. So we'll have to solve for AC. So to solve for AC, let's use Pythagoras theorem. AC square is equal to AB square plus BC square. So AC square is equal to AB is 8 square plus 15 square. That's going to be 64 plus 225. That is 289. So AC will be root of 289. That is 70. So we have got AC. Now we need to find sine A. So sine of angle A. The sine, we know the formula is opposite over hypotenuse. So opposite over hypotenuse. So opposite of angle A is 15. And hypotenuse is the opposite of 90 degree. That's 17. So 15 over 70. Now we need to find sec A. So sec is the reciprocal of cos. Cos is adjacent over hypotenuse. So sec will be hypotenuse over adjacent. So hypotenuse is the one opposite to 90 degree, that is 17. Over adjacent is the one part of the angle, but apart from the hypotenuse. The arm of the angle apart from the hypotenuse, that is 8. So that's how you solve for sine A and sec.
If angle A and angle B are acute angles such that cos A equal to cos B, then show that angle A is equal to angle B. So let's draw the figure. So you have to draw a triangle in such a way that angle A and angle B are acute angles. So let's draw in such a way that A and B are acute. Okay, so now it's given that cos A is equal to cos B. We know that the formula of cos is adjacent over hypotenuse. So cos A, so if you consider the acute angle A, the adjacent of angle A is the arm apart from the hypotenuse. So that's going to be AC, and hypotenuse is going to be the one opposite to 90 degree, that's AB. Now cos B, if you consider angle B, the arm of that angle apart from the hypotenuse, so that's going to be BC, and the hypotenuse is going to be again opposite to 90 degree, that is going to be AB. Now we could cancel AB on both sides, so you would get AC is equal to BC. So I got that these both sides are equal. If those two sides are equal, we can say that from here angle A is equal to angle B using this theorem, that is the angles opposite to equal sides are equal. So hence proof.